So here's a buffer problem for you to try. So how would you prepare a buffer with a pH of exactly 2 from the common acids I've given you on the right hand side in yellow? So go ahead and pause the video and decide what's the best way to make this buffer, and then unpause it and we'll go through it together. Okay, so the first thing to do, right, is to remember that in general, the best buffer is one where the pH and the pKa are almost the same. In fact, we don't really want to deviate more than 1 unit away from the pKa. So if we look at these four here, we can see that clearly the one of choice is going to be this top one here, because this has a pKa almost identical to the pH. At this point here, we can run into the Henderson-Hasselbalch equation. So that says that pH is pKa plus the log of the base to acid ratio. I'm going to just sloppily write it as B to A. And well, let's see, we know pH, we know pKa, so we need to find this ratio. So we can rearrange. So we can say that the log of the base to acid ratio is the pH minus the pKa. And this problem here, this is 2 minus 1.95, right? Because we're going to pick this acid right here, and that ratio is 0.05. So if we want the actual ratio of base to acid, we have to anti-log, and that is 10 to the power. So we would take 10 to the power of 0.05. And on my calculator, I get 1.1 as that ratio. So what exactly is the base we're looking at here? So we've got HCl2. Clearly that is the acid. The conjugate base is exactly the same thing, minus a proton, so that is the ClO2 minus ion. So what we'd have to do is have to have that ratio of those two concentrations 1.1 to 1. Now, how might we find ClO2 minus? Well, we wouldn't be able to find it by itself in the stockroom. We would have to find, say, a salt containing that. And the best kind of salt to be would be a sodium salt, because sodium is neutral and cheap, very importantly. So we would want to get this in a ratio of 1.1 to 1.0, let's say. So we would have, say, maybe a 1.1 molar solution of this thing and a 1.0 molar solution of this thing. In fact, those concentrations are really large. Certainly if you're a biologist, they would probably kill all your organisms. You'd probably want to divide everything by maybe a factor of 10 or 100. So maybe if you had 0.011 molar of this one and 0.010 molar of this one, that would give you exactly the same ratio, but would give you a much lower total ionic strength. So probably the organisms would survive.